So we are going to start section 5.4 today. And we're going to take some time on 5.4 because we need this stuff throughout pretty much the rest of the course. Okay? So, we'll start it today with factoring. Monday, we will factor and do a little bit of solving. Tuesday, you will have a formative in the Resource Center. Wednesday, we will finish up with solving. Okay? So, that is the plan. Okay? So, I am going to give you the 4 steps that you should do every time you need to factor. You want to write these down. Okay? Because you're going to do these every single time. In this order. Okay? When you're confused, refer back to this to tell you, oh, I need to do this. If that doesn't work, I need to do this. And so on and so forth, working yourself down the list. The first step, the first list item is you need to check for a GCF. Anybody know what GCF stands for? Greatest common factor. Okay? So you need to look at each individual term. So 8x squared here is a term. And 20x is a term. And you need to ask yourself, what goes into 8 and 20, and what goes into x squared and x. Okay? And you want the biggest of them. Okay? I could factor out a 2, okay? But that wouldn't be the greatest common factor because both can be divided by 4 and x. Okay? Then, what I do is after I determine what my greatest common factor is, then I go back and I divide each of the terms by that greatest common factor. So that what's inside the parentheses is still the same size as what I started with. So in this particular case, we started with a binomial, a 2-termed expression. So inside my set of parentheses, I should also have a binomial. Okay? So 8 divided by 4 is 2. X squared divided by x is x. 20 divided by 4 is 5. X divided by x is 1. How can I check to make sure that I'm right?
You distribute the 4x back into the parentheses.
And how long will that take me?
15 seconds.
If that. Okay. 4x times 2x is 8x squared. 4x times 5 is 20x. 5-6 seconds maybe. I know that I'm right. I know that I factored it. Yeah. These little things go a long way when helping you factor. Okay? Next thing you look for is you look for the difference of perfect squares. So if I have a squared minus b squared, it has to be subtraction. That is difference. If it's addition, it is not doable. Okay? If it's a squared plus b squared, it is not factorable. Okay? And then this factors to be a minus b and a plus b. It might help for you to write down on the side, on a side column, the perfect squares. Okay? Ready for them? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, that's the first 15. Okay. So, first step, always check for a GCF. So I'm looking at 9x squared minus 1. Any GCFs there? No, no GCFs there. Okay? So then I look to see if it's a difference of perfect squares. So I look here at that term. Is 9x squared a perfect square? If 9x squared is a perfect square, both the number and the variable have to be a perfect square. Is 9 a perfect square?
Yes.
Check your list. Yeah, third one on the list, right? Is x squared a perfect square? Yeah. Side note, does anybody know how you can tell if a variable is a perfect square? Anybody know? Got something to do with the exponent.
If it's positive?
No, we always have
Like
positive.
an even number.
An even number, yep. If the exponent is even, that variable is a perfect square. Okay? If the exponent is a multiple of 3, it's a perfect cube. If it's a multiple of 4, it's a perfect fourth, and so on and so forth. Okay? So 9x squared is a perfect square. It is 3x quantity squared. Is 1 a perfect square? Yeah, the first one on your list, right? Most importantly, do we have a subtraction sign? Okay. If we have a subtraction sign, then it is doable for factoring. So this would factor to be 3x minus 1 and 3x plus 1. What if I wrote it as 3x plus 1 and 3x minus 1? Is that okay? Because order doesn't matter in multiplication. Okay? So don't get hung up on it's always got to be minus then plus. Okay? So that's the second item on our list. Third item on our list is trinomials. Trinomials have 3 terms, hence tri. Okay. Now, you're looking for the product of 2 binomials when you factor a trinomial. Okay? But really, what you're doing is you are, how I call it butt cheeks. Okay? So you're going to fill in the butt cheeks. Okay? Now, here's how you fill those in. The first 2, here and here, multiply together to be that one. Okay? So, what multiplies together to be 2x squared? 2x and 1x. Does it matter if I put 2x first and 1x second, or can I put 1x first and 2x second? Doesn't matter. Okay? Alright? But my only choices there, in this particular one, are 2x and x. What if I had something like 6x squared? Could be 3 and 2, could be 1 and 6, right? Okay? So, Nope, this one. Okay? So, sometimes you might have to guess and check. Okay? Alright? And it's pretty much the only time that I say, yeah, let's guess and check. And then these last 2, the other 2 spots that fill up our binomials, multiply together to be 20. What multiplies together to be 20? 5 and 4? 10 and 2? Is that it? 1 and 20. Okay? So we got 3 choices there. Okay? Now, to cut down on my choices, I look at this number. If that number is big, I take the 2 that are farther apart. So like if that number was something above 20, actually really above 18, I would choose 1 and 20 in there. Okay? If that number is small, which it is, 3 is pretty small, okay, then I'm going to choose the 2 that are closest to each other. Okay? So I'm going to choose 4 and 5. Okay? So I'm going to go 4 here and 5 there. No? Okay? How can you be shaking your head no already, Brett?
I already did it.
Okay? So what should we do now then?
Flip them.
But no, but what, so how did you know to flip them?
Well, it has to equal negative 3x. 4 times 2 is 8. So you subtract 8 from 5.
Okay? So really what we do here is I'm looking at, let me go with with red here. Okay, so I have to multiply those two together, and that got me 4x. And then I have to multiply these two together, and that got me 10x. And somehow between those, adding or subtracting, I have to get down to 3. Right? Can't do it. Okay? So then, we got to flip them. So now I get 5x on this one, and I get 8x on the other one. Okay? So, and I need it to be negative 3. So I need this one to be negative and that one to be positive. So this factors to be 2x plus 5 and x minus 4. The kicker is the check part of guess and check. Okay? You have got to check those to make sure that you factored it correctly. Okay? The fourth way that we're going to learn today is cubics. Now, I think you saw some cubics in Algebra 2. There's really no mathematical, like I could go and I could prove how to do these for you, or I could just give you the formulas. Because they're simply just formulas. Okay? So if I have a cubed plus b cubed, that's going to factor to be a plus b, same sign, times a squared minus ab, different signs, plus b squared. Okay. The downfall with the cubic formula is that this trinomial here is not factorable. Okay. It's not factorable in the end. So when you apply the cubic formula, it's the last thing that you do. Okay? A cubed minus b cubed then is going to be a minus b, a squared plus ab plus b squared. Now, we should probably write down some cubics. Okay? First off, variables. How do I know if a variable is a cubic? See who was paying attention earlier. How do I know if a variable is a cubic?
It's a multiple of 3.
The what is a multiple of 3?
The exponent.
Exponent. The exponent is a multiple of 3, makes it a cubic. Okay? Cubics. 1. Write these down too. 1. 8. 27. 64. 125. 216. 343. 512. 729, 1,000. Okay. Those are your cubics, 1 to 10. Okay. So, let's factor. First, what's the first thing we look for? Greatest common factor. What's the second thing we look for? Difference of perfect squares. Third thing, trinomials. Fourth thing, cubics. Okay? That order every single time. Okay? That order every single time. So, 98x minus 14. What's the biggest number that goes into 98 and 14? Biggest number, 14 goes into 98. How many times? 7. Okay? So that means that I can factor out a 14. What's left over? 7x minus 1. Okay. And that's that. Because there's nothing else that I can factor in that binomial. Now, after I GCF, I forgot to mention this, I should go then and look at the next step just to make sure, and the next step and the next step. Okay? You should make sure that in every problem you're going through all the way so that you're factoring completely. Okay? All right? So, like for instance here on this one, 12x cubed plus 22x squared plus 8x. Numerical greatest common factor is 2. Variable greatest common factor is x. Okay? So I can factor out a 2x. That leaves me with 6x squared plus 11x plus 4. Okay? Now, woohoo! We factored. Okay? But if I'm going on a trip to Milwaukee, let's say, okay, if I'm going to Milwaukee, and I stop in Stevens Point, okay, and I get out at Fleet Farm in Stevens Point, right on Highway 10. Okay? When I get out of the vehicle, can I go, woo! I'm in Milwaukee! Am I? No, I'm still in Stevens Point. Okay? I'm on the way, but I'm not there yet. Okay? So now we got to look at that trinomial. And we got to see if that can be factored. Okay? I'm going to try 2x and 3x. I'm going to try 1 and 4. If I do that, then I get 3x and I get 8x. I add those two together and I get 11x. Nice! So those both become pluses. So my final answer here, factored completely, is this 2x comes along for the ride. And then we have 2x plus 1. And we have 3x plus 4. Okay? And And now I can say I'm in 1. Try those two. Can I go any further with that one? I can?
Yeah.
Why?
Because there's a perfect square.
Perfect square?
Yep.
And a perfect square, right?
Yep.
Can I go any further? Yes or no?
Yeah.
Why not? Because it's addition. It's gotta be subtraction. Gotta be subtraction. Okay? So yes, it looks like I can factor it, but it's not subtraction in there, so I can't. Factor out a 3x. See if that one can. 25 is 5 and 5. 1 is 1 and 1. If I add both, that gets me 10x, so that's good. So this one is 3x times 5x plus 1 times 5x plus 1. That's acceptable. Okay? This is also acceptable. Your dongle?
Yeah.
I have it.
You have it.
Yeah,
That's
I have
just
it.
part of it.
Yeah, it's me. I got it. Using it for volleyball.
Okay.
Yeah. Okay. I can also write it like that. Okay. Again, I don't care which form it's in. To me, they mean the exact same thing. Okay. Here's those cubic formulas again. You try to factor that one completely. So, is 27x cubed a perfect cube? Yes? Because 27 is a cube, right? 3 cubed. And x cubed is a cube, because it's right there in the title. So this is 3x quantity cubed. Is 125 a cube? Cube of what? 5. Okay. So, this would factor to be 3x plus 5. 3x quantity squared is going to be 9x squared. 3x times 5 is 15x. Oops, excuse me. That should be minus because we have to change the sign. And then plus 5 squared is 25. It's not that hard. You know what I mean? It's the binomial is just it without the cubes, right? And then it's a squared, opposite sign AB, plus b squared. It's not that hard. I'd memorize the pattern instead of the actual. Okay. Questions on factoring? So, as I had stated earlier, this is day 1. Monday we'll go through day 2. Tuesday you'll take a formative. Wednesday we'll finish up day 3. Okay? So 4 homework problems due in this first one, which puts us at 4 homeworks due on Monday. Okay? So all good.